friends, welcome to Loksatta Yashasvi Bhava. I am Mrs. Vadke. I am here to discuss and explain the chemistry chapters included in Science and Technology textbook of Standard 10 through a video. Before we start with the discussion, children, I request you to keep your textbook and the articles which are published in the Loksatta Yashasvi Bhava with you so that you understand things better. So children, shall we start with the first chapter, which includes the school of elements. Here we are going to discuss about the classification of elements. I would like you to know, from exam point of view, the weightage given to this chapter is of 3 marks without the option and 4 marks with the option. That means the type of questions which are included in this chapter would be maybe the objective type questions of 1 mark, 1 mark answer the following, or the 2 mark questions could be included here, and also 3 marks questions. Now, time to time I would also tell you about how you are going to write your answers and give weightage to the marks, and discuss different type of questions that are expected to be answered in this particular chapter. So friends, let us begin about the classification of elements. You know that there are various elements that are present in the nature. Initially there were very few elements which were known to us. Scientists tried to classify them in simple possible ways like metals and non-metals. But then with the discovery, they found that there were some elements which had both properties of metals as well as non-metals, and they were termed as metalloids. As time passed, scientists studied the elements and tried to classify them in best possible way. The first scientist who put forward his theory of classification was Sir Prabodhine, who was a German scientist. He observed that the elements were in a group of 3 which had similar properties. But the most peculiar characteristic of these elements are that every center element or the middle element, the atomic mass of this center element was the average of the other 2 elements. For example, lithium, sodium and potassium. If we observe the atomic masses of the 3, the atomic mass of lithium is 6.9, atomic mass of sodium is 23, and the atomic mass of potassium is 39. The average of the atomic mass of lithium and potassium is equal to the atomic mass of the sodium element. Such triads were arranged. The next triad is calcium, strontium and barium. Again here we observe that the atomic mass of calcium is the average of the atomic masses of the other 2 elements. So these triads were possible only with the few elements, but it did not approve or it did not obey the rule for the remaining elements, and hence this theory of triads was discarded. Then came into existence was the Newland's octaves method of classification. The British scientist named Newlands put forward his theory of classification of elements, which is called as the octaves theory. According to this classification, the elements were arranged in the increasing order of their atomic masses in such a way that every 8th element had the similar properties as that of the first element. For example, in the classification of Newland's octave, the properties of lithium were similar to the 8th element to the lithium, that is sodium. Again, the properties of potassium were similar to the properties of the sodium. This peculiar characteristic that the 8th element, the properties of the 8th element is similar to that of the first, was only observed till the calcium element. All the elements beyond calcium did not obey this particular characteristic, and therefore this theory was also discarded. Then came into existence was the Mendeleev's periodic table, which is also called as a short form of periodic table. Mendeleev examined the relation between the atomic masses of the element and the physical and chemical properties of the element. He concentrated more on the chemical properties of the elements because these elements reacted well with oxygen and hydrogen. He arranged the elements in the increasing order of the atomic masses of the elements and concentrated on the chemical properties. He studied the relation between the atomic masses and the chemical properties of the elements and prepared a periodic table based on the same. By then, 63 elements were known. He successfully arranged the elements according to the increasing order of their atomic masses. He arranged the elements in the horizontal rows in the increasing order of their atomic masses till he encountered another element showing the similar chemical properties, and then began the next row. For example, lithium had the similar chemical properties as that of sodium. So the third row began with the sodium. The further elements were again arranged in the increasing order of their atomic masses till he came across another element showing the similar chemical properties, which was placed in the fourth horizontal row. Thus he successfully arranged all the remaining elements in the Mendeleev's periodic table. Now let us discuss the merits of Mendeleev's periodic table. Mendeleev successfully arranged all the known elements in this short form of periodic table. He had left 3 vacant places for some undiscovered elements, namely Ika boron, Ika aluminium and Ika silicon. He had also predicted the properties of these undiscovered elements, which then he named them as scandium, gallium and germanium. After the discovery, they found their place and occupied the place in these vacant places, thus completing the Mendeleev's periodic table. By then, even the inert or the noble gases were discovered and found place in the Mendeleev's periodic table and occupied the position without disturbing the position of other elements in the short form of periodic table. Now, let us discuss the demerits of Mendeleev's periodic table. Hydrogen, which had the properties of alkali metals as well as halogens, did not find a fixed position in the Mendeleev's periodic table. In the Mendeleev's periodic table, some of the elements having higher atomic weight was placed before the element having the lower atomic weight. For example, cobalt, having atomic mass 58.9, was placed before nickel, whose atomic weight is 58.7. Some of the elements having dissimilar chemical properties were placed in a group of elements having the similar properties. Example, manganese, which was placed in a group of halogens, had totally different properties as compared to the halogens in the group of halogens. Children, so far we have discussed about the 3 types of classification of elements, namely the Daubernius triads method, Newland's octaves method of classification and Mendeleev's classification. More details are discussed in the articles given in Loksatta Yashasvi Bhava. Now let us discuss the type of questions related to this particular topic. Children, you know that the weightage given to this chapter is of 3 marks. So what type of questions are expected from this particular topic? You may expect the 1 mark questions related to the objective type or answer the following for 1 mark, which is related to the Daubernius triads method. For example, you may expect any objective type questions related to the triad like lithium, sodium and potassium. Whereas 2-mark questions based on discuss the merits or the demerits of Mendeleev's periodic table. Whenever you are writing the points of these merits or demerits, do not forget to mention the examples in every point. If you don't write these examples, you may lose over 50% of marks. That is, you may just get 1 mark out of 2. So don't forget and underline the examples for the convenience of the examiner. Similarly, when you are stating the Newland's octaves, you may be asked a question like, state the Newland's octaves method of classification. Do write the method of classification again by giving at least one example, so that you score full 2 marks for stating the Newland's octaves method of classification. Similarly, you may be asked a question, state Dauvergne-Streyer's method of classification for 2 marks. Discuss the answer, write down the proper statement. There again by giving one example. You may give any example like lithium, sodium, potassium, or calcium, strontium and barium. Any one example, so that you get full 2 marks for the required question. Children, we have discussed about the questions asked on the earlier topics. Now let us study the Moseley's periodic table of classification. As time passed by, more and more elements were discovered, and hence the existence of Moseley's periodic table. This is also called as long form of periodic table or modern periodic table. The main features of this periodic table are: the modern form of periodic table has 18 vertical groups and 7 horizontal groups. The elements were arranged in the increasing order of their atomic number and not atomic masses. This is the main difference between the Mendeleev's periodic table and Moseley's periodic table. The 7 horizontal rows included the elements which were arranged in the increasing order of their atomic number. The first row of the first period is called as the shortest period because it includes only 2 elements. The second and the third period is called as the short period because they include 8 elements in each. The fourth and the fifth period is called as the long periods, are called as the long periods because they include 18 elements in each. Whereas the sixth period is called as the longest period because it includes 32 elements. And the last horizontal row, which is the seventh period, is the incomplete period. Children, you will observe here that the most peculiar characteristic of these horizontal rows is the number of shells occupied by a particular element represents its period number. For example, let us take lithium. The atomic number of lithium is 3 and hence its electronic configuration is 2 and 1, which means 2 shells are occupied in case of lithium, hence it belongs to the second period. Similarly, sodium, which has atomic number 11, its electronic configuration is 2, 8 and 1. Hence, it occupies 3 shells. Therefore, sodium belongs to the third period. You can check out with all the other elements which are given below, and you will observe that the number of shells will indicate the period number. Now let us see and discuss the 18 groups which are shown in the modern periodic table. We observe that there are 18 groups and the elements are arranged in such a way that they go in the increasing order of their atomic number. The most peculiar characteristic of these groups are that the number of valence shell in the particular element represents the group number. For example, let us take beryllium. The atomic number of beryllium is 4, hence its electronic configuration will be 2 and 2. The number of valence electron is 2, hence beryllium will belong to the group 2. Let us take another example, say fluorine. The atomic number of fluorine is 9, hence its electronic configuration is 2 and 7. The number of valence electrons are 7, hence fluorine will belong to the 7th group. You may also check out with all the other elements which are given in 18 different groups. You will see that in the modern periodic table, the last group, that is the 18th group, is also called as a 0 group here. It includes all the inert or the noble gases. Now, this modern periodic table is also, it depends upon the electronic configuration, and hence it is divided into 4 blocks, namely the S block, the P block, the D block and the F block. The S block elements are the first 2 groups, that is 1 and 2. The first groups are called as alkali metals and the second group is called as alkaline earth metals. Then the P block elements are from group number 13 to 17 and also includes the 0 group. Whereas the D block element starts from the 3rd group to the 12th group. They all belong to the D block elements, which is placed in the center of the modern periodic table. Then the 4th group is the F block, which is there, which is placed at the bottom of the periodic table. These F block elements are also metals. You will observe that the most different or the peculiar characteristic of the D block elements are that they include metals, the non-metals, and the zigzag line which is in between indicates the metalloids which are there. Therefore, in general, we can say that the S block elements have all metals, D block elements have all metals, F block elements also includes all the metals, whereas the D block elements has all the 3 types of elements, that are metals, non-metals and the metalloids. Children, there are not many details given about this modern periodic table in the textbook as well as in the article given in Loksatta Yashasvi Bhava. You may check out with all the details in this article. Now let us discuss what are the type of questions that are expected to be asked based on this particular topic. First, you know that the full weightage of this chapter is just for 3 marks. So, maximum of 3 mark questions can be asked from this particular chapter. Now, related to this particular topic, you may be asked first type of question, that is distinguish between, for 2 marks, distinguish between Mendeleev's periodic table and Moseley's periodic table, which will be for 2 marks and you are expected to write down 2 points for the same. Then, a 2 mark question related to give reasons from 0 group elements or from the 7A group elements. Every question that you answer from this, you may take or give one example of each to score those 2 full marks. Children, now let us discuss about a few questions based on the periodic properties in the modern form of periodic table. A 2 mark question can be asked related to the size of the atom. How does it vary in a group? You may see that in the group from top to bottom, the size of the atom goes on increasing, because as you proceed from top to bottom, the number of shells go on increasing, thereby the size increases from top to bottom. First, don't forget to mention about what is atomic size. It is the distance between the center of the atom and the shell of a particular element, atom of a particular element. Then, a 3 marks question can be asked that define the atomic size, how does it vary in a period and in a group. So here you have to mention about any one period and any one group. a period, for example, if you take the third period from sodium to argon, the size of the atom, it goes on decreasing from left to right. Now why does it decrease? In the third period, we see that the first element is sodium and the last element is argon. The number of shells though remains the same. The number of electrons goes on increasing from 1 to 4 in silicon, and then it goes till chlorine, the number of electrons will become 7. Therefore, these negatively charged electrons will get pulled towards the nucleus, because nucleus consists of the positively charged protons. Therefore, the size of the atom will go on decreasing from left to right. And then discuss about the size of the atom, as I have discussed earlier, in a group, how it goes on increasing from top to bottom. For a 3 marks question, you have to discuss in detail about both the horizontal period as well as the vertical group, giving one particular example to score full 3 marks for the answer. Children, if you have any doubts or queries regarding this particular chapter of School of Elements, you may email us on loksatta.com or Yashasvi Bhava for the query.